Hi, a beautiful day everyone. So for today, we're going to be talking about limits of a function. We're going to show you how to use theorems and limits except theorems 6 and 8. And later on, after we discuss all the theorems, we're going to show you how you can apply limits on your real and daily lives. So before we start, let's have first a background about limits of a function. So the limit of a function describes how a function behaves as the independent variable gets closer to a certain number. The concept of limit is also fundamental in the study of calculus. So we're going to be talking about theorems 1, 2, 3, 4, 5, and 7. So without further ado, let's get started with Theorem 1. Theorem 1. So Theorem 1 is just basically easy. Theorem 1 states that limits of c is equals to c as x approaches a. So Theorem 1 is limit of a constant. So that c means constant. So let's proceed to the example. First one, limits of 6 is equals to blank as x approaches 2/3. So the answer is 6. Why? Because 6 is a constant. As stated on our rule, limit of c is equals to c. Therefore, the answer is 6. Number 2, limits of negative 5 is equals to blank as x approaches 3. The answer is negative 5. No matter what the sign is, positive or negative, as long as the number is constant, that will be the answer. Lastly, example number 3, limits of 5 over 7 is equals to blank as x approaches 0. So this is a fraction. The answer is still 5 over 7 because it is constant. So no matter what x approaches, as long as the limit is constant, therefore the answer will be the constant as well in Theorem 1.
Now that we're done with Theorem 1, I'm going to teach you Theorem number 2. It states that for any number a, the limit of x as x approaches to a is equals to a. That means that x is equivalent to the value of a. Now for you to understand it better, I've prepared some examples for you. Let's have this equation. The limit of x as x approaches to 7 is equals to 7. The value of x is equivalent to the value of a, or the answer, which is 7. Then in Theorem 3, it states that the limit of f of x as x approaches to a is equals to a, and the limit of g of x as x approaches to a is equals to b. Then in addition, the limit of f of x plus g of x is, as x approaches to a is equals to the limit of f of x as x approaches to a plus the limit of g of x as x approaches to a is equals to a plus b. In difference, the limit of f of x minus g of x as x approaches to a is equals to the limit of f of x as x approaches to a minus the limit of g of x as x approaches to a is equals to a minus b. To illustrate, we're going to apply our sum or difference rule. The limit of 2x plus 3 as x approaches to 1. In this example, we have the plus sign, so we're going to apply our addition. According to our rule, this can be written as the limit of 2x as x approaches to 1 plus the limit of 3 as x approaches to 1. Get the constant, which is 2, times the limit of x as x approaches to 1 plus apply the Theorem 1. Our constant is 3, so the value of this is 3. So we have 3 times. Now we're going to apply our Theorem 2. According to number 2, we have the limit of x that is equal to where we are approaching, which is 1 plus 3. So 2 times 1 plus 3 is equals to 5. So now let's use the difference. We have the limit of 3x minus 5 as x approaches to negative 1. Applying our theorem, that is equal to the limit of 3x as x approaches to negative 1 minus the limit of 5. Next step, we have 3 times the limit of x as x approaches to negative 1 minus, we need to use theorem number 1, that is equals to our constant, which is 5. Now we have 3 times use theorem 2, that is negative 1 minus 5. So 3 times negative 1 minus 5 is equals to negative 8.
Okay, so now let's talk about Theorem 4, which is all about the product theorem. This theorem can be applied with functions that has a multiplication as their operation. Here, let's have our first example, which is the limit of 4x as x approaches 2. To solve this example, let us first separate the two terms as seen in this presentation. So it will be the limit of 4 as x approaches 2 multiplied by the limit of x as x approaches 2. In this example, we can see that we can use the theorems that we learned earlier, which is the Theorem 1 and Theorem 2. So here in our first term, which is the limit of 4 as x approaches 2, we can apply the theorem number 1. As we apply theorem number 1, limit of 4 as x approaches 2 will be simply 4 since it is a constant. On the second term, we can use theorem number 2, which is about substitution of the values. So the limit of x as x approaches 2 will be 2. Then, after we're done solving them separately, we can now multiply the two values together, which is 4 and 2. So to get our final answer, let us multiply 4 by 2, which will be equal to 8. And 8 is our final answer. Now let's discuss theorem number 5. This theorem is all about quotient theorem. As you can see here in our presentation, this theorem can be applied in functions that has ratios and divisions as their operations. Now let's have our example. So here we have our given the limit of x over the quantity 2x minus 1 as x approaches 3. So first thing we need to do is to separate the two terms. So this will turn out as the limit of x as x approaches 3 over the limit of the quantity 2x minus 1 as x approaches 3. So here we have our first term, the limit of x. We will use once again the theorem number 2. So we will substitute the value. So this will turn out as 3. Next, for our second term, we have the limit of the quantity 2x minus 1. What we will do is to substitute again the values. So this will turn out as the quantity 2 multiplied by 3 minus 1. So then 2 times 3 is equals to 6, minus 1 is 5. So our final answer is 3 over 5. Now we're done with theorems 4 and 5. Just remember, first separate, 2 solve, then that's it.
Theorem 7. Theorem 7 is a power theorem. Theorem 7 states that limits of 1 over x to the power of r is equals to 0 as x approaches a. So, suppose we were given a limits of x squared minus 6x plus 4 over 2x squared plus 5 as x approaches infinity. So, mostly Theorem 7 is used in infinity approaches. So infinity, obviously we cannot try all the numbers to figure out what it is. So what we're gonna do is to apply theorem 7, which will be the inserting of a denominator. But how can we know what denominator are we gonna put? So you just need to figure out what is the highest exponent from the given. So here we have 2 as the highest, therefore our denominator will be x squared. So now let's apply it and insert it in all of the givens one by one. So x squared over x squared, 6x over x squared, 4 over x squared, and then over 2x squared over x squared, and 5 over x squared. So we have a final answer of 1/2. How did that happen? So from all of that, it's just 1/2. So let's start by evaluating it. So x squared over x squared is simply 1. And then 6x over x squared, 4 over x squared, and 5 over x squared is 0 or cancelled. Why? Because it states on the theorem 7 that any number over x is equals to 0. Therefore, the remaining numbers are 1 and 2, as 2x squared over x squared is equals to 2. Since the remaining number from the upper is just 1 and from the lower is 2, that will be our final answer, 1/2.
Hi guys, so today I am going to show you how we can apply limits in real life. Limits are so flexible that we can use it in real life circumstances, situations such as bank limits, speed limits, and many more. And today I'm going to show you how we can apply limits in real life. Supposedly, I am driving this car at 60 miles per hour, on which I can't do because I can't drive and I'm a minor. So yeah. And I want to know how much distance I can travel for 3 hours. I can use the theorem 4 as follows. Limit of 60t as t approaches 3, where 60 is equal to speed of car in miles per hour, and the 3 is the time in hours. I can use the theorem 4 and substitute t with 3 to get 60 times 3, and 60 times 3 is equals to 180. Therefore, the distance traveled by the car in 3 hours is 180 kilometers. The concept of limit is so flexible that we can use it in real life situations, such as bank account,